Welcome, everyone. My name is Brett Peterson. I'm the Director of Sales and Operations for North, Central, and South America. Thank you for joining us today. As a point of introduction, Isograph has been creating and improving engineering software for over 32 years. Our headquarters is in the UK, and we have an office here in beautiful Alpine, Utah. I'd like to introduce you to Dr. David Wiseman. He will be conducting our presentation today. He's our lead technical support for Isograph and corporate trainer. David has been with Isograph for over 13 years and worked with thousands of organizations, helping their employees become conversant with our software tools. Today, David will be giving a high-level overview of one of our software modules. Now, if you find this training useful and want to learn additional information, please contact us directly. And let me just share our contact information here. You can reach out to any three of us here. I've got David, obviously, on the line here, myself, and my sales manager, Clint Armitstead. Any of us would be happy to help you at any time. So with that being said, today we'll be discussing our software tool that covers our attack tree software, and I'll turn the time over to David here. Let me share my screen with you, David. Here momentarily, you'll be able to see David's screen, and I'll have him start the webinar and go through it from here. Thanks, David.
Okay, no problem. Thanks very much, Brett. Hi, welcome everybody. Thank you, Brett, for the introduction. So I'm David. Today I'll be taking you through the features of Isograph's attack tree software. Now, if you're at all familiar with our software, you may know that a number of our tools are in fact suites of different tools for different types of reliability and availability analysis. So you can buy access to, you can essentially cherry pick the types of analysis that you need to do. Our attack tree tool, in many respects, is no different. It's a sort of smaller suite of tools with modules for different forms of threat analysis, for identifying and analyzing threats to a system due to deliberate attacks, and then analyzing the potential impacts of those attacks and how you might go about mitigating those impacts. So you should be able to see now on the screen our attack tree suite. If I click on the menu at the top left here, you'll be able to see just a little list there of the different tools that exist within the attack tree software. So there is a threat analysis tool, which we'll look at first. This is a tool for identifying the threats to a system and ranking them by their level of risk. There is the attack tree tool itself. So here is where you can identify potential paths to an attack and then rank those paths of attack by their severity, by their criticality, by their probability or likelihood. And with the attack tree module, there is also a mitigation tree facility as well. So here, once you've identified maybe the frequency or the probability of a successful attack, you can then look at the frequency or probability of different outcomes from that attack based on the success or failure of different mitigating systems that you put in place. We'll start by taking a look at threat analysis. So the threat analysis tool, very simply, will allow you to create a hierarchy of blocks. These are the green blocks that you can see on the left here. Those can just be added from the toolbar or the menus. Each of those blocks will represent a system or a subsystem. We call them assets. Essentially, these are the assets that an attacker might try to damage or gain access to. So I've got an example open here of an automotive system. So obviously these days, there's a great deal of connectivity, even in automobiles, where there are onboard computers that control different systems within that vehicle. And potentially hackers could try to gain access to those systems to cause mischief. So, for example, I have an asset block that represents my braking system. And I can describe what that system does. And I can build a whole hierarchy this way, blocks that represent systems, subsystems, individual pieces of equipment, or even components within that system, whether they are hardware or software or anything else. Now, underneath any one of these asset blocks, I can then begin to identify the threat to those assets. So, for example, for my braking system, I've identified two threats, maybe an attempt to override the braking system and an attempt to disable or cause a malfunction of the collision detection system. Now again, those can be added just via the buttons on the toolbar or in the menus. And if we open one of these objects up, you can see here you can, of course, describe what the threat is, but you can also rank that threat by different criteria. Now, one of the key criteria is going to be likelihood. How likely is it that this threat is going to happen? And there are a couple of ways that you can approach this in the software. You can create what we call a likelihood object. This is an independent object. You can see a list of them already defined here in my project that represents the likelihood of any given threat. So I can create as many of these as I want, again, from the menus, and I can rank them by frequency or by likelihood level. And when I create a threat, if I wish, I can just choose what the likelihood is. Now, it's not always that easy. One of the issues we come across a lot when we're talking to our clients about threat analysis and attack tree analysis as well is that actual numerical information about the likelihood or the frequency or probability of a threat is extremely difficult to come by. It's not like reliability analysis where you can go to the manufacturer of an electronic component and ask them for the MTTF or calculate it in a failure prediction standard. Working out the frequency with which somebody's going to try and bypass your firewall or something like that, it's not an easy thing to do. Often, threats, rather than being ranked by an actual quantitative frequency value, are ranked by what we call indicators. Basically, you can rank a threat by the level of expertise that the attacker needs, the level of knowledge or the amount of equipment or the cost. Basically, you can rank the likelihood of a threat based on the obstacles faced by the attacker. So the harder it is to perform the attack, the less likely that attack is to actually occur. So here, for example, I've specified that someone needs to be an expert in order to perform this attack. They need certain critical information. So maybe this threat is relatively unlikely simply because it's quite hard to perform this attack. And you can see back on the General tab where I've asked the program assign likelihood based on indicators. The likelihood is considered to be virtually negligible. The program has arrived at that conclusion simply by comparing the indicator ranking values that are pulled from these rankings to the likelihood level that you might have seen a moment ago in the likelihood properties. Now, besides the likelihood, you can also weight the likelihood value by the controllability. What is the probability that you have a certain preventative measure in place? For example, a firewall. I can say there's a 78% chance that the system is protected by an up-to-date firewall, and that can be used to weight the likelihood calculation as well. And for any given threat, you can also specify consequences. What are the potential impacts of this threat? And you can do that in up to 10 different categories. I'm going to close that and just show you on the left here where, well, for one, there's the controllabilities. Again, you can add these from the menus very easily. At the bottom, you can see here is where I have defined all of these consequences. So I can double click on one of these and I can give the consequence an ID and a description and a weight, a numerical value, dimensionless, that indicates the severity of this particular threat. So we can define the assets that someone might wish to attack. We can define the threats that might represent those attacks and the impacts they might have. We can specify how likely that threat is to occur based either on numerical information we have available or indicator rankings stating how hard this threat would be to actually pose by the attacker. We can specify controllability, and we can specify the impact, the consequences of that threat. But really, the main thing we want to do with a threat analysis is to rank our threats by the risk that they pose. And we can define risk using the risk levels, which we can create right down here at the bottom of the hierarchy. Again, that's all done via the menus. So let's open up one of the risk levels that I've created already. So here you can see I've created this risk level. It represents medium impact. I've given it a color code, so I can just use a standard Windows color palette to color code my risk rankings. And then for each risk ranking, I can specify basically, I guess, an upper bound on what is the risk coming from a given threat. So what's going to happen is the program is going to calculate the risk of a given threat by multiplying the frequency or the likelihood of the threat by the weight of the consequence. It will compare that risk value to the values given for each of these different risk levels, and basically by working out which range the threat falls into, it will allocate a risk level. And it can do that for, well, again, up to 10 different categories of risk. So one of the things that we'll find is that as we're doing this, as we're setting up our likelihoods and our consequences and our risk levels, based on the values we're giving the program is able to automatically construct a risk matrix based on this information. We can actually view it. If we take a look at the special functions menu at the risk matrix, and you can see here my consequence matrix for safety, where we've got the likelihood values on the left, the consequences across the top, and then the program has allocated risk levels to each combination of consequence and likelihood based on the risk level boundaries that we defined. So the program has just set this matrix up automatically based on the values we've given it already. And so then, basically all the program is going to do is look at the likelihood and the consequence assigned to each threat, compare it to the matrix, and then allocate a risk level. Here I'm just displaying the risk level for safety, but you could also display it for environment or economic impact or whatever impacts are particularly important for your analysis. But I can see here things like, for example, internal vehicle network attack. This kind of attack is a high risk, whereas maybe something like control override is relatively low risk. So I can rank my threats according to the risk, and that might sort of prompt me to move on to a different form of analysis, to look at this DDoS attack on the vehicle network and think, okay, there's quite a high risk from this problem. Maybe I should escalate this now to an attack tree. So to summarize the threat analysis, here you're building a hierarchy that represents your system, identifying the threats to those systems, ranking those threats by their likelihood and their impact, and then the program can use the risk levels that you provide to automatically rank each threat by its level of risk, whether that's safety risk or economic risk or whatever else. So from there, I'd like to move on to attack tree. So attack tree, maybe a lot of viewers are already familiar with the concept of a fault tree. Now, in a fault tree, you define a given hazard or failure, some kind of problem in a system about which you want to learn maybe the frequency or the probability. So you want to know the frequency with which a certain hazard will occur, and you can build a logic tree that represents the combinations of different component faults, conditions, operator errors that might lead to that hazard. So, it could be pump failures or electronic component failures, or maybe an engineer makes a mistake during maintenance. And all these things come together to cause some kind of system hazard or failure. An attack tree follows a very similar procedure, but instead of dealing with hazards due to failure, whether they're systematic failures, random failures, operator failures, here we're looking at hazards that are coming about as a result of deliberate attacks against a system. So here you can define a top gate, much as you would in a fault tree, but now that top gate doesn't represent maybe a reactor rupture or a system shutdown. It represents a successful attack, a successful attempt to in some way access or harm a system from the outside. That can then be linked to other logic gates. Those gates might represent other forms, maybe different forms of attack, different ways in which this attack could be performed. If I page down, look a little further, I can see different other paths that an attacker might need to take in order to perform that attack. And at the roots of the attack tree, where in a fault tree you would see basic events that represent the failures of components or failure modes of components, here we might see an attempt at a certain form of attack, an attempt to access a system, and then other events that represent conditions or probabilities of failure on demand or preventative measures. So here, for example, a Sybil attack might occur, if an attacker initiates a pseudonymity attack, and at the same time, maybe the vehicle allows unvalidated registrations to be used, maybe the roadside unit is compromised. So basically, if there are all of these problems in your security system at the point when an attacker attempts to access your system, then there will be a successful attack of the variety specified. So this works much the same way as a fault tree does. In a fault tree, you build the gate and event structure to represent the different paths to failure. In an attack tree, what we're analyzing is the different paths of attack. Here, the minimal cut sets, the minimum sets of events which together will cause the top event to occur, these represent all the potential paths of attack that an attacker could follow. So what information then goes into a basic event or an event in an attack tree? Well, there are a couple of options that a user can follow. If we open up one of these events, we can provide initiator or enabler data. An initiator is the triggering event, the event which, when it occurs, will trigger the successful attack. And for that, we can provide a frequency value. Conversely, an enabler is an event which already must be in effect, an event that's already happened at the point that the initiator occurs. In this case, it might be some kind of issue with my security system. If there's a problem with my security system and then there is an attack, that's when we have a problem. And for those kind of events, we can provide a numerical probability. But this just brings us back to the problem we discussed earlier with threat analysis. It's all very well being able to provide these probability and frequency values, but they are quite difficult to come by, often impossible in certain situations. So what other options do we have to basically express the likelihood of these events? Again, we can use indicators. So we can enter indicator values or define and select indicator options. The indicator options are shared between threat analysis and attack tree. So you can see here a list of indicators. So I've got indicators for expertise, for knowledge, for equipment. Each one of these has a value associated with it. So for any event, if I open it up, I can go to the indicator tab and either enter an indicator value directly or select one of the options that I set up in my project tree. So let's go back to the top of the tree and run an analysis and see what comes out. We can run the analysis, and if we take a look at the final results, well, one of the things that we can see, let's say we take a look at the top of the tree, we can see the frequency with which a given attack is expected to be successful. But maybe that's not a realistic thing. Maybe it's not going to be so easy for us to get this probabilistic information for our basic events. So instead, we might think, well, let's forget frequency and probability. Let's think in terms of those indicators about how hard it is to actually perform this attack. The best place to look for that information is under the minimal cut sets. So you remember we said the minimal cut sets are these sets of events which together trigger the top event. They trigger the successful attack. So these are essentially our paths of attack. These are the events or the things that the attacker would have to do or rely on in order to perform the attack successfully. And for each one of these paths of attack, for each combination of events, there will be a set of indicators. So you can essentially rank the paths of attack by the combinations of indicators. So you can say, okay, this path seems to be fairly difficult. If we go further down, some of them look much more easy. So we can look at the paths of attack, see which ones are expected to be more or less difficult, and then rank them by their likelihood in that way. Now, one of the things that it is possible to do in an attack tree that is not possible through a conventional fault tree is to assign a consequence. If I open up a top gate and go to the consequences tab, you can see here, kind of like we did in the threat analysis, we can assign consequences to a gate. So I can say, if this attack is successful, what is the impact on safety, on finance, on operation, and so on. And again, if we look in our results, the program can, for example, show me the paths of attack that might lead to certain consequences. So, I can select any consequence that I've used in my tree and just see what paths of attack might lead to that consequence and look at the potential indicators, how difficult that path of attack would be to perform. The program is also capable of calculating risk. You remember, risk is the frequency or the likelihood frequency multiplied by the weight of the consequence. But remember, this is going to be dependent on providing frequency and probability information in your tree. And as we said, more often than not, that's a bit too difficult to come by. So if you have that information, that's great. You can do a risk analysis like this, but often you'll find yourself working with these indicators instead as a more effective way of ranking the likelihood of these paths of attack. So if the threat analysis is how we identify the threat, and then the attack tree is how we maybe analyze the potential paths to that threat, to that attack, then the mitigation tree is how we might then analyze how we might prevent that threat from causing greater problems. So maybe for this, I will open a different example file. So here I have an attack tree where I've calculated the probability of an unauthorized access to a network. what I can do then is say, okay, I now have an idea of how likely it is someone might access my network without my permission. I'm going to go to the mitigation tree and now think, okay, well, what are all the potential outcomes and what are the risks from those outcomes? What the mitigation tree will allow you to do is basically start with your threat and then define a variety of different columns that represent the different mitigating conditions, different mitigating systems that might be in place. And then depending on the success or failure, the logical state of the conditions, you will get better or worse consequences. So for example, let's say there is unauthorized access to my network, but the user account that was used didn't have very high privileges. All of my sensitive data was encrypted. The encryption is of a very high standard. And after there was this unauthorized access, I was able to make a strong press release to reassure all of my customers. In that case, I would have relatively small consequences, just minor damage to reputation, very minor loss of data, maybe not very sensitive data. Conversely, if there was unauthorized access to my network, but the attacker somehow had got administrative privileges, my sensitive data wasn't encrypted at all, and I had some kind of issue with a press release, maybe I gave a very nervous, very poor interview in front of the cameras, then there would be far more damage to my reputation. Of course, there'd be a great deal more data loss. And again, as we saw earlier, if we run this analysis, we can take a look at the results. And one of the things we can get is we can look at the consequences that we've tied to the ends of each of these branches and say, well, okay, what are the different paths that could lead to major damage to my company's reputation? I can look at the cut sets, see what paths might lead to that problem. And again, I can rank them by the indicators, by difficulty, by cost, and so on. And of course, if the probability information is available, I can do a risk analysis as well. So here, not only am I able to look at the probability or the likelihood of a threat, I can also look at the likelihood of all of the potential outcomes of that threat, depending on how well I'm able to guard against the consequences. And these two modules, attack tree and mitigation tree, are linked. So it is possible, if I double click on one of these branches, to actually link the branch to a given event or gate in my attack tree. So I can actually pull the paths of attack, pull any probability data through from the attack tree into my mitigation tree, and use that information then to look at the potential outcomes of the attack. So I think all that's left to point out is just that, as with all of Isograph software tools, there are very powerful integrated reporting facilities. So here you can, for example, display lists of results. You can display plots of data, and naturally, you can open reports that will display your diagram. So if you wanted to, for example, put your attack tree into a PDF that you could share with colleagues or with potential clients, you can do that from here very easily. And if you have, say, lists of consequences or indicators or other information that you plan to use in your threat analysis or attack tree or mitigation tree, and you're keeping it in something like, let's say, Excel, the program has extensive import and export facilities as well. So I'll just show briefly some of the formats that are available. So you can import and export information to and from the likes of Excel, Access, SQL Server, and even just straightforward text files. So if you have data in a spreadsheet and you don't want to spend hours typing it all in by hand, probably you'll just be able to import it directly. So that's everything I was going to show with regards to the attack tree tools. So I'll just pass back over to Brett. So do you have any questions or anything you'd like to add?
No, I really appreciate it, David. Thanks for sharing that overview today. I know that this tool is something that has a very broad reach, that every company, that's out there is having these concerns and needing a software package like this. So I really appreciate you, giving us that overview. Now, if you have additional, questions or anything else, I'm going to share my screen just for some contact information. You can also download a free demo of our attack tree tool and start playing around with it, model some things. And so once you've done that, please let us know. We'd love to, be a resource going forward for you. But really appreciate everyone's attendance today, and everyone have a fantastic day. Thank you all.